All right, we are going to look at this section to review. Uh, we recently talked about plate tectonics, so this should be pretty fresh in your minds. So if you'll go to page 129 in your green book, um, remember this idea of our Earth being divided up, like the external crust being divided up into different pieces. It really came about from this guy named Alfred Wegener. So Alfred Wegener was this man, and he started looking at the continents around the world, and he first looked at Africa and South America and looked at how they looked like they kind of fit together, right? And then he started playing around with the different continents. Like maybe at one time they were this supercontinent, right, called Pangea. And so he started doing some research, and he found that there was this word fossils, plants and animals of the same species that existed in continents that, if you look at our globe today, that are separate by an ocean, right? There's oceans between Africa and South America. There's oceans between these continents and Antarctica. There are oceans around Australia. The question was, how do these plants and animals get from one place to another? His idea was this continental drift theory. So here's the word continental drift. You can read more about it. He just believed that once the continents were together and that Earth's these tectonic plates are moving, and they have moved these continents away from each other, and they're still moving today. Like it hasn't stopped. That was his theory, but he couldn't prove it. He couldn't prove it until during World War One. There was that Henry Hess, yeah, Henry Hess, and he was a Navy guy, and he was mapping the ocean floor, and he discovered this area called the Mid-Ocean Ridge. And what it is, if you look on one of our globes, this is Africa, right? And this is South America. And in the middle of this Atlantic Ocean, right here, Mid-Atlantic Ridge, is this kind of underwater mountain ridge. And what's happening is these tectonic plates are spreading apart, right? And this magma is coming up, and it's causing these plates to diverge or move away from each other. And this is called causing a phenomenon called seafloor spreading. And this is what gives credence or validity to this whole tectonic plate movement. You might see a mention, I'm not sure, it's called magnetic striping. And what they found is on this seafloor that they can date stuff. They know how old stuff is. That there is new. I'm so sorry. That's a mess. This crust or this bottom of this ocean is younger or newer, and as you get further out, it is older. Which means that this new floor is coming up, that magma is cooling and spreading. So the new stuff is here, and it's getting pushed. The older stuff is getting pushed, and it creates this striping effect on the ocean floor. If you look on page 133 here, there's 133. These are plates, and most plates are tied to a continent. So we have the North American plate. That's where we live. The South American plate, the African plate, the Eurasian plate, right? Europe and Asia. The Indo-Australian plate. This is India, and it's part of this puzzle piece called the Indo-Australian and the Pacific plate. So remember, our globe is round, so that's why this Pacific is on both sides. It would wrap around. So our tectonic plate, it borders the Pacific plate. This is all ocean. Now, we also learned that these plates are moving, and our Earth looks the way it looks because of these plate movements. So, we talked about the types of crust. So, we have continental crust and we have oceanic crust. So, this would be an oceanic crust, right? Pacific Ocean crust. This would be a continental crust. Oceanic, continental. Oceanic, continental. Right? So you have different kinds of Earth. They do different things when they move. They can either converge, that word you have to know, convergent, it means come together. Converge, C-O, convergent, come together, C-O. They're coming together. And when they do that, they can do two things. They can, what we say, collide, meaning one comes here and one comes here. This occurs when you have two continents coming together. And they push so hard against each other that they make a mountain, right? Neither one is going to go under. They could come together. And when they come together, you might have one, when it gets here, it decides it's going to go under. This occurs when you have ocean crust and continental crust. That ocean crust is more dense. It sinks down. It goes down to the bottom of the ocean run. It's heavier. So when they come together, it goes under. It will start to melt. And as it comes up, it will form a volcano. All right, that will form a land volcano. You can also have where this occurs, I'm going to draw it over here, where you have ocean and ocean crust coming together. And the older ocean crust, when it comes, it will go under. It is more dense. Again, it will melt here, and that melting magma will come up and it will form a volcano. But because it's ocean now, this is going to create an island, a volcanic island. All right, so convergence can form mountains or volcanoes. You also might have plates that diverge. Remember, we talked about that mid-ocean ridge here, where they diverge or they go away from each other. So they move away from each other in opposite directions. And what happens is that magma comes up, right? That magma is going to come up if this is under the water, and you're going to have new crust is formed. And we call that the mid-ocean ridge. Okay. This might also happen on the continents. And if it does, what happens is that land, this happens, it's called a rift valley. It happens in Africa. These plates are moving away from each other. And what happens is this area begins to sink, right? And it forms this valley. And it's called a rift valley. This also occurs in the ocean. You can have rift valleys form also. So when they move away, they form a rift valley, or they can cause this mid-ocean ridge. That's that ridge of mountains from that new magma coming up, okay, on the bottom of the seafloor. And the final movement is this side-by-side thing, where you have one plate coming one way and one plate going the other way. And where this occurs is right here. So you have the North American plate going this way. You have the Pacific plate. That ocean plate is moving down. And this is called a transform boundary. And what happens is these two plates, right, are moving. And as they push like this, they kind of get caught on one another and they pop, right? All that energy like that. And then you get that earthquake. In fact, you can have an earthquake in any of these movements, but it's really severe in these transform boundaries. So they're going to slide past one another. They form these faults. They form a fault. And a very important one is the San Andreas Fault, which is in California. So if you see a question, they probably will talk about this one. So it causes earthquakes. Alrighty. This information should prepare you for these 5 questions. So if you will do those 5 questions. Alrighty. Thank you very much. Once you finish that, if you have any time left, you can do something quietly on your computer. These questions will be graded assignments, so make sure you get them done.